Okay, let's see. Get a light on here and do a little auto focusing. And I am going to start and finish inverse functions in this period of power that I've got. Okay, inverse functions. This is a simple little section, pretty basic in terms of not much more than one little thing. F of -1 is the inverse. That's how we talk about the inverse of the function. The inverse of the function is literally just the x's get up and swap places with the y's. That is literally what we're going to do. I'll show you how that works in just a second, but you know that a function itself, in order to be a function, you have to pass the vertical line test. A function has an inverse. We can talk about an inverse for the function. Function has an inverse if it passes the horizontal line test. Then it is called a one-to-one function. And it can be inversed. For instance, let me do a sloppy for you here. If we've got that passes, that is a function. A parabola is a function. It passes the vertical line test. But it does not pass the horizontal line test, so it does not have an inverse. It is not a one-to-one function. So this would not have an inverse, and it would not be a one-to-one function. However, if we do something like that, half of the parabola, that passes the vertical line test, we know it's a function. It also passes the horizontal line test, so it would have an inverse, and it is a one-to-one function. Let's say we take a line that goes like, let's say that passes the vertical line test, so it's a function. It would also pass the horizontal line test, so we could do an inverse of it, and we would call it a one-to-one function. One last one. Let's do something wacky-do like that. That passes the vertical, so it is a function, but it would not pass the horizontal, so we could not inverse it, and it is not a one-to-one function. Okay, literally what we are going to do in order to find the inverse, like I told you, is to reverse the xy. So if we have a point AB, when we make the inverse, we are literally just going to swap them out. We're going to make the x coordinate be the y coordinate and the y coordinate be the x coordinate. What is going to happen is that is going to offer reflection across the identity function. So it's going to be a reflection across the y equals x line. And we'll look at that a little bit more. I don't even think we look at it in this one, but later we will. Okay. Is it an inverse? Does it float? Is it an inverse? So let's say that we have got f of x equals 5x minus 9, and we've got g of x is x minus 9 over 5, and we want to know, are those inverses of each other? Let me show you the steps that you take in order to do an inverse, if you've got it written as an equation, and then we'll do that a couple of times. First thing we're going to do is we're going to replace f of x with y. So let's do that in this one. We've got f of x equals 5x minus 9. Let's change it to y equals 5x minus 9. Then we are going to swap out the y and the x, literally going to have them change places. So now we're going to swap out the y and the x, so we will have x equals 5y minus 9. The third step is we're going to solve for y. So we're going to solve for this guy now. So in order to do that, I'm going to move the 9 over. Of x plus 9 equals 5y. And then I'm still solving for y, so I'm going to divide everybody by 5. So I get y equals x plus 9 over 5. And then the last step that we need to do is replace y with f of -1 of x, the inverse, f to the -1 of x. So I'm going to change this to f to the -1 of x equals x plus 9 over 5. Remember, the original question was, are these inverses? And I blew it because I'm not going to re-record. Mistakes happen. This one should have, so are these inverses of each other? No, they are not inverses of each other, because the inverse of f of x equals 5x minus 9 is x plus 9 over 5. That's the inverse. What I had so these are not inverses of each other. Notice that this has a minus 9. That has a minus 9. That's not an inverse. This has a 5 times x. That has a divided by x. That part is an inverse. What I meant to do, just read it wrong, was this was supposed to be a plus. So let me go through and correct that. That's a plus. I swapped out. Remember, I first replaced the f of x with the y. So I got a y there. Then I swapped these out, so this would still be a plus. Next thing I would have done is I would have moved this 9 over, and it would have been a minus 9. Then I divided by 5. This would still be a minus 9. And then I replaced the y with f to the -1 of x, and this would still be a minus. Now they are inverses of each other. Notice what I'm doing here. I'm adding 9 on this one. I'm subtracting 9 here. Those are inverses of each other, inverse operations. I'm multiplying times x. I'm dividing by x. Those are inverse operations of each other. So these 4 steps still hold. We'll use those 4 steps a couple of times. Let's do a couple of them. Let's find the inverse of f of x equals 10x. Let's do that one first. First, replace the f of x with y. Second, swap out the y and the x. We're finding the inverse, so literally we are getting them to trade places. So I'm going to have x equals 10 times y. Next, solve for y. I'm going to divide by 10. So I get y equals x over 10. And then finally, replace that y with the inverse. F inverse of x equals x over 10. There's the inverse function for this original function, and they are inverses of each other because we did the 4 steps. Notice this one is 10 times x. This is x divided by 10. That's an inverse operation. Let's do another one. Let's say that we have got f of x equals x plus 1 to the 3rd power, and we want to get its inverse. Let's follow these 4 steps. First, replace f of x with a y. You know that f of x and y are the same things. Second, swap out the y and the x. Literally have them trade places. Next, solve for y. We want to get y by itself. So the first thing I have to do is get rid of that 3. I'm going to take the cube root of that side. Cubing and uncubing cancel each other out, so I have a y plus 1 there. Whatever I do to one side, I have to do to both sides. So I end up with the cube root of x there. I've still got a job. I've still got to, in solving for y, I've got to get rid of this 1. So minus 1 will give me a y, and this will be the cube root of x. Don't put the minus 1 underneath there. He's free and clear. And then finally replace. The inverse of x equals the cube root of x minus 1. Notice in this one we had a we had a cubing of x. Now we've got a cube root. That's an inverse. We had a plus 1 on the x. Now we've got a minus 1 away from the x. So we've got the inverse there. That's the answer. the inverse function. And these can swap out. You can have the f of minus 1 to the x first. That would be fine. Okay, we've got a couple of graphs to look at. We want to draw the inverse of this one. Let me focus again just in case. Okay, we want to draw the inverse of that line. First off, does it have an inverse? Yes, it passes the horizontal test, so it does. We can do this. Let me set up a t-table. I think that's going to be the easiest way at this point. Let me find some points that I've got. I can see going through, oh, that's a good point right there, going through right at target. So 2, 3 is one of my points. There's one that's -1, -4, -1, -4. That's probably good enough. 2 lines determine a point. That's the function. Let's look at the inverse. So f of -1 of x, let's set that up. Literally, the x and the y trade places. So instead of 2, 3, we'll have 3, 2. Instead of -1, -4, we'll have -4, -1. Okay, let's draw those. 3, 2, 1, 2, 3, 1, 2, right there. And then -4, -1, right there. That line is our inverse. So if this is f of x, this is f of -1 of x. That's our inverse. Something that matters here is that these two inverses of each other will be reflections across the y equals x line. Across that parent graph y equals x. If that were the mirror, the function and its inverse are reflections of each other. All right, let's do a couple more like that. Given this equation, f of x equals -2x plus 1, we want to first find the inverse. Let's do it the way that we were doing it. First step, we want to swap out the f of x, or sorry, we want to call the f of x y. Y equals -2x plus 1. Then we want to literally swap them out. X equals -2y plus 1. Then we want to solve for y. So I'm going to first move the 1 over. Then I'm going to divide by -2. And then the fourth step, well, let's see, let me correct this up a little bit. So that gives us y equals x minus 1 over -2. And so then I want to replace the y with f of -1 of x, the inverse. X minus 1 over -2. Okay, so there's the function. I want to graph both. I'm going to correct this into looking like y equals mx plus b. So I'm going to move this over. F of -1 of x equals x over -2, and then it'll be -1 over -2, so it'll be plus 1/2. There it is in y equals mx plus b. Okay, let's first graph our first one. I'll do that in blue. This is y equals mx plus b. Start at +1. The slope tells you to go down 2 and over 1. I seriously need a straight edge. There's the function itself. Now let's look at graphing its inverse. So I'm going to start at 1/2. There's my b. And then remember, this is go up 1 and down 2. Go up 1. No, you can't go up 1 and down 2. Sorry. Rise over run. Go up 1 and to the left 2. Go up 1 and to the left 2. So we end up there. Let me use my straight edge. Something like that. And those two are reflections of each other across the y equals x. So that's a reflection. The blue line is a reflection of the orange line. Graph both. Okay, we did that. Now use interval notation to give domain and range of both. They're both going to be negative infinity to positive infinity because we have no breaks. These are just lines. The blue goes all the way to the left. Takes it a while. Goes all the way to the right. Same with the range. I mean, they're just lines. So the domain here is negative infinity to positive infinity for the function itself, f of x. The range on the blue line is the same. It goes all the way down, all the way up. And now let's look at the inverse function. The domain of the orange line, the domain is going to go negative infinity to positive infinity. Nothing fancy going on there. And then the range for the orange line goes all the way up, all the way down. Same thing. What we'll notice when we do our third one is that whatever the domain is for the first one, for the function itself, that's going to match the range of the inverse. Because remember, they just literally get up and trade places. So the range for the function will also match the domain of the inverse. They will, and this you can't tell because they're all the same. Okay, let's look at our last one of the graphs. We've got x squared minus 5, but only for x is greater than or equal to 0. So this is a parabola. You know that, and you know how parabola looks. We're moving it down 5 on the y-axis. So 1, 2, 3, 4, 5. Let me put that here in blue. So right there, over 2, up 4, something like this. Something very close to that. That is a parabola that is x squared minus 5, move it down 5, but only show the parts that are here, that are on the x. That's so that, because if we did it all, it wouldn't pass the horizontal line test and we can't play with it as an inverse. But if we keep it restricted just to here, then it does pass the horizontal and it does have an inverse. Okay, so let's go through those 4 steps. We've got f of x equals x squared minus 5. What I want to do first is call that y equals x squared minus 5. Second step, literally swap them out. Third step will be to solve for y. First thing I'm going to do is move the 5 over. And then in order to solve for y, I've got to take the square root. That gives me a y that is eventually going to be f of negative 1 equals x. That'll be our 4th step here. But first thing, if I've taken the square root of one side, I have to take the square root of the other side. So I've got the square root of x plus 5 equals y, and that'll give me the square root of x plus 5 is the inverse. Okay, so we have graphed this guy. Let's now go and graph this guy. Remember that the square root of x, that's the shoulder. That's the shoulder that starts here and goes like that. What we want to do, though, is we want to transform it. We want to shift it. Under the x, you know that's a liar, so we're going to move it back 5. 1, 2, 3, 4, 5, and it's going to come from there. 1, 2, 3, 4, 5, right there. Something like that. And look at there. That is a reflection across that parent y equals x graph. These are reflections across there. Let's use interval notation to give the domain and range of both. So first, for the f of x function, the domain, that's the blue one. What are we using up on the x-axis? We go left to right on the blue. Ignore the orange right now. Just the blue. The domain doesn't, no blue, no blue. Oh, right there at 0. We've already been given it. X has got to be greater than or equal to 0. So our domain is 0 to infinity in interval notation. That's what we're using up of the x-axis. Push this up, pull this down. What is it using up on the x-axis? Just from 0 to infinity. The range on the function itself, what are we using up of the y-axis of the thermometer? Shove this blue guy over to the y-axis and look. We don't start using him up until right there, until -5, and then we go on up to infinity. Okay, so for the inverse function, let's look at domain. Now we're looking at the orange guy. The domain that we use there, start on the left. Nope, 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 nope. Oh, right there we start using the x-axis. So we begin using the x-axis at -5, and it goes all the way out to infinity. Let's look at the range. The range is the y-axis. So ignore the blue, looking only at the orange, scoot him over to the y-axis. You're looking at what does he use up of the thermometer. This part of the thermometer we are very familiar with right now, aren't we? So scoot this guy over, that's 0. So we don't use, the orange does not dip below here. The orange starts at 0 and goes on up to infinity. And looky there, the domain of this guy and the range of the inverse match. The range of the function and the domain of his inverse match. Because literally that point got up and swapped his x and y and became that point. Okie doke. That's it on the 3 graphs worksheet page. Let's do a little bit more of this kind of stuff. Let's see, let me make sure I'm done with that. Yep, we're done with that. Let's look at 2 sets of points. Let's call this x and f of x. And straighten that out a little bit. And then let's call this x and g of x. We're going to play with these for a little bit. First point here is 1, -6. We got 3, -2. We got 5, 1. And we got -3, 2. Over on this one for x and y, or g of x, pairings, we've got -2, -5, 1, -2, 8, 2, and 5, 1. It's just 2 sets of points. Remember, this is x and y for the function that is f. This is x and y for the function that is g. They're not related to each other in any way. Let's first find f of g of 5. Okay, you know enough about these that you know we're going to start in here. Let's find g of 5 first. So we know we're going to the g function. They're giving us the x. We're finding the y. So go over to the g function, find where the x is 5, right there, and you give them the y. It's a 1. So we're trying to find f of 1 because g of 5, go to the g function, look where x is 5, that equals 1. So now we're trying to find f of 1. Go to the f function, that's over on this side. They're giving you the x. There's the x. You tell them the y. And there's the answer. Let's do another one of those. Let's find f of -1 of g of 1. Okay, don't worry about this so much. Let's worry about this part. We know how to do this part. We'll worry about, this will be a new part for us. This was a reminder. Now let's go learn something new. Let's look at g of 1. Go to the g function. That's this one over here. Find where the x is 1, right there. You want to give them the y. That's -2. So that business, g of 1, is -2. Find the x. They gave you the x. You find the y. Now let's go find the inverse of -2. What that's telling us is that they are giving us the y. We're going to give them the x. Or another way of thinking of it, we could build the t-table. You know that inverse will just be the swap of this. -2, 3, 1, 5, 2, -3. Let's first look at it with ignoring this. Just ignore that business right there for right now. So we're asked to find the inverse of -2. So we want to go down this list, down the y list. They're not giving us the x if they're telling us we're looking at inverse. They're giving us the y. This is the inverse. The x's and y's swap out. So you go look on the y list right there until you run across the x. So we've got a 3 there, and that's the answer. Or if you prefer, you swap out the list knowing that this is the inverse. Just reverse. X stands up, gets in the y position. They just say, excuse me, and swap places. So now we're looking under the f of -1 list. They're giving us the x, we're giving them the y. One of those two ways you figured out. Okay, one last thing. F of x equals 2x minus 5. G of x equals 3x minus 5. And h of x equals x squared plus 4x plus 6. And we are asked to find g composed of f, not composed of, sorry, g of. Okay, I think I got that, whatever. Lots of parentheses. Okay, g of f of h of 2. Got 3 steps to do here. You know to go here first. Pause this if you know what to do, if you have a theory. There's nothing new in this particular problem, nothing having to do with inverses in this problem. So pause it if you want to and see what you can do. Let's start with h of 2. Let's go to the h function, that's this guy, and plug in our 2. So h of 2 is going to be 2 squared plus 4 times 2 plus 6. That's 4 plus 8 plus 6, 12, 18. So that business right there is 18. So now we're all about finding g of f of 18, because h of 2 is 18. So now let's go find f of 18. That's the first one. So f of 18 is 2 times 18 minus 5. 2 times 18 is 36. 36 minus 5 is 31. So f of 18 is 31. And finally, we're going to go find g of 31. So go after the g function. G of 31 equals 3 times 31 minus 5. That's 93 minus 5, and that gives us 88. And that's the final answer. So G of f of h of 2 is 88. Okay, that's it. We're done for the week. I will see you on Monday.